Find moment of inertia of a rectangular lamina of length A and breadth B about axis passing through its center of mass. So you have a rectangular lamina. What's the meaning of lamina? Lamina means very thin sheet of negligible thickness. There is no thickness. What is the significance of this lamina? The lamina actually means is whole mass of the body is distributed on its surface only. There is no thickness, right? So you have to find moment of inertia of this sheet about three axes passing through the center of mass. One is this axis, one is it rotates about this axis, and one is when it rotates about this axis. It's given that its length is A and breadth is B. So breadth is given to be B and length of the sheet is given to be A. Okay, let's start with the most easier part. Let me find the moment of inertia about this axis first. So this is my lamina of length A and breadth B, right? I need to find moment of inertia about this axis. Let's say it is I1. This is I1, right? So how to do it? Step number 1, divide the given rigid body into infinitesimally small elements whose moment of inertia we already know, also which makes our integration easier, right? So what type of element I can choose so that it makes my problem easier? We can think of this rectangular lamina to be made up of very fine strips that I have shown. One is this strip, another can be this strip, another can be this strip. These are very thin strips of width, let's say DL, right? Please keep in mind you have to divide your given figure into such elements whose moment of inertia you already know, right? So question is, do I know moment of inertia of any of these strips about this axis? Yes, I do know. We'll see it very soon, right? Next step is focus on one such element. So what element we took is, we took it very thin strips. So I am going to focus on one such strip. Let me assume this strip, any general strip, right? At any general strip, not at the beginning, not at the end, but at any general distance, right? Next step is write its address. Okay. Let me say this is origin. This is x is equal to 0. This is equal to x is equal to x. Next is write its dimensions. I need to write its dimension, that is length as well as breadth. So continuing with the same variable, I'm not introducing extra variable. Thickness of the strip, let's say it is dx, right? Since I have taken this as x-axis, since the thickness is along the x-axis, so thickness is dx. Don't take it dl, otherwise you will introduce one more variable here. What will be length of the strip? It is going to be same as b, right? It is b. So we have written its dimension as well. Next is write its mass. So what is the mass of this elementary strip that we have chosen? It's very easy. dm equal to mass per unit area into area of this strip, right? Why I have taken mass per unit area? Because it's very thin lamina. That means whole mass is distributed on its surface only. So mass per unit area into area of this fine strip. Let me say it is dA. What is the area of this fine strip? That's pretty easy. dA is equal to length into its breadth, b into its breadth dx, right? So we have written the mass. Last step is write moment of inertia of this element about given axis. Element, what I have taken is this thin strip. So I have to write the moment of inertia of the strip about this axis. Now focus here. You have an axis. I am interested in finding moment of inertia of this strip about this axis. Very easy to visualize. If you see, this strip can be thought of tiny particles, right? Tiny particle like this, each of mass, let's say dm, and all the particles of the strip are equidistant from this axis, and that distance is, let's say, x, right? So what will be the moment of inertia of this mass? That is going to be dm into x square, right? And again, what is the moment of inertia? This particle about this axis, again dm x square, plus what is the moment of inertia of this particle about this axis? Again dm x axis. So it is dm x square plus dm x square plus so on till it covers all the particles. So you just need to add it. It will be x square common, dm plus so on and so forth, right? So it is going to be dm plus dm plus dm plus dm. All these particles will lead to mass m. What is m? M is the total mass of the strip, right? So moment of inertia of the strip about this axis is nothing but mx square, right? See, the result is very similar to a point particle. अगर एक कोई point particle m mass का x दूरी के ऊपर होता है, तो इसका moment of inertia about this axis also mx square, right? ऐसे ही क्योंकि ये thin strip है और पूरी की पूरी strip equidistant है from your axis of rotation. That's why I'm getting same result mx square, right? If you remember, even if we have ring, right, ring का भी जो moment of inertia होता है that is mx square, where x is this distance. Why? Because all the particles of the ring, they are equidistant from this axis. That's why we get the result mx square, right? So we know what is the moment of inertia of the strip about this axis. This is equal to di, that is small moment of inertia. It's equal to mass of the strip, right? Its mass is dm into distance from the axis. What is that distance from the axis? This is x is equal to 0, this is x. So this distance is nothing but x. So dm into x square. Putting the value of dm, that is m upon a. Here you can substitute the value of area. Area of this whole lamina. You can write this as m upon a into b dx. So b is gone. So here I can substitute m upon small a, right, into dx. So this is mass into x square. So moment of inertia of complete body I'll get by integrating this result, that is m upon small a x square dx integration. M is constant, this is mass of complete lamina. A is the length of this lamina, again it's constant. Now it's time to put the limit. Limit will be of x. Here I have to put the x of first element. Here I need to put the x of last element. Okay, your first element. See, element I have taken thin strips. This will be my first element, first thin strip, and this is going to be my last element, last thin strip. What will be the x value of this for this element? This is going to be x is equal to minus a by 2, right? And final element का जो x होगा, this is going to be x is equal to plus a by 2. क्योंकि ये पूरा का पूरा जो length है, that is a, width is b, right? Length is a. So this is minus a by 2, that is plus a by 2. So here you need to put minus a by 2, here you need to put plus a by 2. You just need to integrate. So final moment of inertia about the given axis is 1 by 12 ma square. That means if you have a strip like this of width a and breadth b, the moment of inertia about this axis is equal to, let me say I1, 1 by 12 ma square, right? Similarly, if somebody says find the moment of inertia about this axis, what will be the moment of inertia about this axis? It is very, very simple. अगर इसके अबाउट मोमेंट ऑफ इनर्शिया 1 by 12 ma square है, तो इस एक्सिस के अबाउट बाय यूजिंग द सेम स्टेप्स आई विल गेट मोमेंट ऑफ इनर्शिया 1 by 12 mb square. Please try to visualize this result. So coming on to the final figure, अगर ये लेंथ a है, then moment of inertia about this axis is 1 by 12 ma square. If this length is b, then moment of inertia about this axis is 1 by 12 mb square. Now, last part, what is the moment of inertia about this axis? The axis which is passing through center of mass and perpendicular to the plane of this lamina. This is the lamina and this is perpendicular to the plane of lamina. What is the moment of inertia about this axis? This is my problem. Let's calculate. To find moment of inertia about this axis, I am going to use perpendicular axis theorem. What is perpendicular axis theorem? For perpendicular axis theorem, you require three axes. All these three axes should be mutually perpendicular to each other. अगर तीनों एक्सेस एक दूसरे से परपेंडिकुलर हैं, यानी कि this axis is perpendicular to this axis is perpendicular to this axis, so all axes are perpendicular to each other. Since all these three axes 1, 2 and 3, they are mutually perpendicular, so I can call them x-axis, y-axis and z-axis. And focus करिए, y-axis and x-axis, they are in the plane of the lamina and z-axis is perpendicular to the plane of the lamina. Okay. So what perpendicular axis theorem says is, moment of inertia of this lamina about z-axis, yani ki an axis which is perpendicular to the plane of this lamina, Iz, is equal to moment of inertia about x-axis plus moment of inertia about y-axis. यहाँ पे आपको mistake नहीं करनी है. These two axes must be in the plane of the lamina, right? Must be in the plane of lamina, and both should be perpendicular to each other. And this axis should be perpendicular to the plane. जो जनरली बच्चे मिस्टेक करते हैं, they write sometime Iy is equal to Iz plus Ix. This is a wrong statement. Why? Z-axis and x-axis, they are not in the plane of the lamina, right? Z is perpendicular to the plane of lamina. So please remember this result. And also you need to keep two more points in the mind. First point, all these three axes must be passing through a common point. ये point का center of mass होना कोई जरूरी नहीं है. Right. Next point that you need to keep in mind, perpendicular axis theorem is only applicable to a thin sheets, that is lamina. Okay, so I know what is moment of inertia about this axis. If this is A, so about it, this axis is 1 by 12 ma square. And if this is B, then moment of inertia about this axis is 1 by 12 mb square. Right, we know Iz is going to be Ix plus Iy, that is going to be 1 by 12 m a square plus b square. This is your final result about the axis which is perpendicular to the plane of lamina.